In today's video lesson, we're going to do some examples together so we can get you ready for the test. Today we're going to focus only on finding the volume of rectangular prisms. And you should remember from class today that we found that the formula for volume is the area of the base times the height. So let's take a look at the formula here. We've got area of the base. What's that? Yeah, the base is this part here of a rectangular prism. And how can we find the area of the base? Do you remember? Yeah, we can find first we'd have to measure the length, this one here, and the width, and we would multiply that together to find this total area. So the area of the base, this part here, is length times width. And then if we just kind of copy this down, times height. So those are the two different ways to represent or to write the formula. Now let's apply that formula to a problem. Let's try example number 1 together. So example 1 says, which box has greater volume? And we have to explain why we think so. So, how should we start? Yeah, let's find the volume of the first box, the volume of this box here with the red base, and compare it to the volume of the second box with the yellow base. Alright, let's do the red one first. So the red one, and what's our formula for volume? So volume equals the area of the base times height. Alright, so our volume then is, well, if we look here, our area is already found. And how did they get 24 centimeters squared? Well, they would have multiplied the length times the width, 8 times 3. So these two multiplied together, right, gave us the area. So 24 centimeters squared. And what's our height? Well, our height is this one here, so 7. So 24 times 7 is, well, 20 times 7 is 140, and 4 times 7 is 28. So if we add those two together, we can get a total volume of 168 centimeters. And what's our unit for volume? Yeah, cubed. Okay, or you could say 168 cubic centimeters. Now that we found the volume of the red box, let's find the volume of the yellow box. Okay, so again we're going to get area of the base times the height. Okay, and our area of the base is this yellow part here. Again, they've already found it for us. It is 56 centimeters squared. And how did they get that? Well, again, if we multiplied the length times the width, because that's this part here, that would give us 56, because 8 times 7 gives us 56. All right. And the height, well, the height of this box is here, or here, or here, but all of those have a length of 3. So 3 centimeters. Ugh, what's 56 times 3? Well, let's break 56 up into 2 parts again. So we could times 50 times 3. And then there's 6 left over from 50, so 6 times 3. 50 times 3, well, 5 times 3 is 15. So 50 times 3 is 150 because we just add the 0. And 6 times 3 is 18. So, oh, look at that. The volume of this prism is also 168 centimeters cubed. Why do you think so? Well, I just noticed something. If we multiply 3 times 8, then times 7, does that really matter if we go 3 times 8 times 7? Or 7 times 3 times 8? No, it doesn't really matter. Anytime you're multiplying 2 or more numbers together, the order doesn't matter. You'll end up at the same spot. So, both prisms have a volume of 168 centimeters cubed. So the question asks us to explain our reasoning. So we need to write a sentence to answer this question. When it asks us to explain, we got to explain why. So, what did we find? Well, which box has greater volume? They're both the same, so we can say that the volume of the prisms were both 168 centimeters cubed. And we can say because they had the same dimensions. Remember, dimensions is the different ways we can measure things, different directions. Both have the same dimensions of 7 by 8 by 3. Okay, let's try question number 2. Determine the volume of milk in this carton if it is half full. Interesting. So because the volume is less than 1, then we know we'll be working with fractions. So this here is really important, half full. How can we write half full as a fraction? Well, 1/2 is written like this, and we want to find half of the volume of milk. When we want half of something, what's the operation that we're using? Of. Yeah, multiplication. So half of the volume. Okay. So first we're going to have to find what the volume of the full carton is. So let's do that first. So the full volume is what we're finding, is the area of the base, so 4 times 7, times 7, and then times the height, 12. Okay, let's do 4 times 7 first, so that's 28. Finally, 28 times 12 is, I just got my calculator out, and that's 336 units? Yeah, centimeters cubed. Okay, so if we want to find half of the volume of this carton, right, half of this, then what are we going to do? Yeah, so, we could divide this number by 2 because we know we want half, or we could times it by a half. Okay, because it's half of the full volume of the milk carton. Okay, so I'm just gonna kind of make some space here for the second part. So 1/2 of the full volume was 336. Okay, so if we want to solve this here, we're working with fractions. So we're going to have to give this number here a denominator of 1. Because any number, we can say that it has a denominator of 1. And what do we do when we're multiplying fractions? Yeah, we just multiply straight across the top and straight across the bottom. So 1 times 336, well, 1 times anything is that thing. So 336. 2 times 1 is 2. So that's why when I said, we can divide by 2, that's why we're dividing by 2. So 336 divided by 2 is 168 centimeters cubed. And that's our final answer. So I'm just going to circle that. Now, the next part of the question asks us to determine the volume of milk in the carton if it's 3/4 full. So this makes it a little more difficult. So if we were to divide this carton here into 4 parts, so we could divide it in half first, and then half of a half is 1/4. So that's roughly 4 parts here. We want 3/4. Okay, so we can do the same kind of process that we did for the last question. So because it says 3/4, all right, well, what is a quarter as a fraction? Yeah, a fourth is a quarter, just like we have 4 quarters in a dollar. And it says 3/4, so 3/4 full. All right, and we're going of the full volume. Okay, so that means 3/4, of means times, and the full volume was 336 centimeters cubed. All right, again, write this as a fraction. Okay, and we're going to multiply straight across. Okay, so 3 times 336, I just got my calculator out, and that equals 1008. And we're going to divide that by 4 times 1. So 4 times 1 is 4. And now I divided 108 divided by 4 in my calculator, and I got 252 centimeters cubed. And that's our answer for the second one. Notice that because it's 3/4 full, we know it should be less than the total if it was full, right? So that's a good little mental check. And of course, we've got one more of these kind of problems. It's ask us to determine the volume of milk in the carton if it is 1/4 full. So this is quite similar to what we actually just did. So again, we're working with quarters, so we can divide it in, let's do that. We can divide it in half first, and then half of a half is 1/4, which is what we want to find. So we want to find just this quarter. Or any of these quarters would be the same. Now, what's left? Yeah, we got 1 quarter left, 2 quarters, 3 quarters. So we have 3 quarters left, which is actually what we just found. So how can we use the information from the last problem to solve this one? Okay, so we know the volume of the full carton, right? And if we minus the 3/4 volume, that'll give us the 1/4 volume. Because a quarter plus 3/4, right? So 1, 2, 3, 4 quarters is a full quarter. So if we subtracted 3/4 volume from the full, that'll give us the 1/4 volume. Let's do that. Do you remember what the full volume was? Yeah, 336 minus the 3/4 volume, and I'll just tell you here, that was 252. Okay, when we subtract those numbers, we get 84 centimeters cubed. So that's the volume of the milk if it is 1/4 full, or we could say 3/4 empty. Yeah, so that's our answer there.